So to find the initial mass of the dime, we must first convert the amount of newtons which we got was 0.00829, and we will get 0.845 grams. Next, we have to write out the net ionic equation, which is Ag plus Cl minus, and we get AgCl. To find the mass of the silver from the precipitate, we must first find the mass of the precipitate, which is AgCl, and then through stoichiometry, we can see that the mass of the silver that is produced is 0.725 grams. To find the percentage of silver in the dime, we have to do the mass of the silver divided by the mass of the dime times 100%, and we get 85.8%. For the class, most of the class got under in the range of 80 to 90% silver. For our error analysis, because we know that the actual dime composition is 90% silver and 10% copper, we know that 90% times 0.85 grams, which is the mass of the dime, equals 0.7605 grams of silver. Therefore, taking our yield of silver, which is 0.725 grams, and we subtract 0.7605 grams of silver divided by 0.7605 grams and multiply by that by 100%, so we get 4.67% error. Some possible explanations for this are that some precipitate escaped or the scale malfunctioned. In conclusion, the results were fairly successful because the lab produced almost all the silver that was used in the dime. However, our hypothesis of 75% was not supported. In the future, we can implement methods for identifying other substances or develop a method to identify the copper side of the dime, which is the 10%. And also, in order to improve the precision and accuracy, we can improve the procedure and materials. Lastly, we'd like to acknowledge Mrs. Ismore for buying the dimes and the materials to do this lab.